Hello class, in today's video we're going to be balancing chemical equations for more complex chemical reactions. Now if you guys recall from a previous lesson, we looked at what the law of conservation of mass was. We said that all chemical reactions need to actually follow the law of conservation of mass in order for that reaction to actually occur. The law of conservation of mass states that matter is neither created nor destroyed in a chemical reaction. What does this mean? Well, it means that mass is conserved when reactants are converted to products. So when a chemical reaction proceeds, if you initially start off with 100 grams of reactants, you're still going to end up with 100 grams at the very end because matter is neither created or destroyed. This also means that there's the same number of atoms of each element on both sides of the chemical reaction as well. So, and in order for us to balance a chemical reaction, we do that by adding in coefficients, meaning the number in front of the chemical formula, so that it is balanced and it follows the law of conservation of mass. We're now going to be looking at a few examples of how to balance unbalanced chemical equations. So what we need to do whenever we're balancing these chemical equations is we need to construct the table as shown below to actually do this properly. So first of all, we're going to list down all the elements in the chemical reaction. We can see that there's barium, chlorine, hydrogen, sulfur, and oxygen. And then all you need to do is just count the individual atoms in the reactants as well as products. We can see that there's one barium atom, two chlorine atoms, there's two hydrogen atoms, one sulfur, and four oxygens in the reactants. In my products, I've got one barium, one chlorine, one hydrogen, one sulfur, and four oxygens. Once you finish doing this, all you simply do is just check off to see which one's balanced and which one's not. So in this case over here, we can clearly see that barium is balanced, sulfur is balanced, as well as oxygen. So what we need to do is balance the number of chlorines and balance the number of hydrogen atoms. In order to balance the number of chlorines and hydrogens, what I need to do is I need to add in a coefficient. Can we see that there's on the product side over here, we've got a fewer amount of chlorines and a fewer amount of hydrogens. In order for it to be balanced, we need to add a coefficient in front of this molecule over here so that the number of chlorines and hydrogens is balanced. In this case, we're going to add in a 2, and by adding in a 2, my chemical equation is now completely balanced. Let's look at another example. So this example over here is a bit more complex because you're dealing with polyatomic ions. And this is where students often make a mistake because they forget to actually multiply everything inside the bracket by the number outside. So again, all we do is list down all the elements and start counting. So in my reactants, I've got one barium, I've got two chlorines. Now this is more complex because you've got nitrogen as well as hydrogen found inside the brackets. This 2 over here indicates you need to multiply 2 by everything inside. So 2 multiplied by the number of hydrogen atoms, which is 1. So 2 times 1 is equal to 2. So if I've got 2 nitrogen atoms, 2 multiplied by the number of hydrogen atoms, which is equal to 8 in this case over here. The number of carbon is 1. Number of oxygen is equal to 3. Do the same thing on the right hand side. So I can see there's one barium, one chlorine, there's one nitrogen, there is 4 hydrogens, there is 1 carbon and 3 oxygens, and then count which atoms is balanced. So we can see that barium, carbon, as well as oxygen are all balanced. We need to balance the number of chlorines, nitrogens, and hydrogens. So what we do first is we'll first balance the number of chlorines. So notice that you've got a fewer amount of chlorine atoms on my products. So I need to add a coefficient in front of this molecule which contains a chlorine in order to balance it. So what we'll do is we'll add a 2 over here, but remember by adding a 2 here, this also affects the number of nitrogens as well as the number of hydrogens as well. I now have in total 2 chlorine atoms because 2 multiplied by 1 is equal to 2. 2 multiplied by the number of nitrogens, which is 1, so 2 times 1 is 2. 2 multiplied by 4 is equal to 8. And now by adding a 2, notice that this just nicely balances all the other elements. So now this chemical equation is now completely balanced. It's time for you guys to actually attempt this question on your own. So please pause this video right now so you can answer the question. What you're trying to do in this chemical equation is that you need to write firstly the unbalanced chemical equation. So going from a diagrammatic representation to a chemical description, and then add coefficients in front to actually balance it. So give yourself 5 minutes or so. But if you guys need extra clarification, over here, the red atoms or the red circles, this indicates oxygen atoms. This represents the sulfur. The white atoms over here indicates hydrogen atoms. So therefore, you should be able to write down the chemical equations by yourself. So please have a go and then compare your answers with mine after 5 minutes. Now, if you've done this successfully, the unbalanced chemical equation for this given reaction is shown here below. So this is what you should have. I'm now going to start adding in coefficients to balance this chemical equation. So what we do again is just set up the table to balance the chemical equations and list down all the elements. I can clearly see that there's only one sulfur atom on the reactants. There is 2 oxygen atoms and there's 2 hydrogen atoms. I then count the number of atoms on the right hand side. So there's 1 sulfur, there's 1 oxygen. Now notice that in my products, I've got hydrogen sulfide and I've got water molecule. Each of these products or each of these molecules contain 2 hydrogen each. So therefore I've got 4 hydrogens in total in my products. I now check to see which one's balanced. So the number of sulfide is balanced. I need to balance the number of oxygen as well as hydrogen. So I can see that the number of oxygen in my products is less. So I need to add in a coefficient in front of water to balance the number of oxygen. In this case, I'll add a 2 in front of water, and by doing so, this now balances the number of oxygen. So I've got 2 oxygens now, so this is nicely balanced. But remember, by adding a 2 there, this affects the number of hydrogens. So now 2 multiplied by 2 is equal to 4, and 4 plus the 2 over here is equal to 6. So 2 plus 4 is equal to 6. That's how I've got the number of hydrogen atoms. So now oxygen is happy, but notice that the number of hydrogens isn't actually balanced. So I need to add in a coefficient in front of hydrogen gas in this case. So I'll add in the number 3, and by having 3 groups or 3 molecules of hydrogen, this will give me 6 hydrogens in total on my left hand side, and now my chemical equation is now balanced. Now, so far, we've currently looked at examples that predominantly involved only adding in one single coefficient to balance the chemical equations. So as you can see over here, I'm only adding in one number in front of a chemical formula. But for the rest of this video, we're going to be looking at more far challenging examples that require you to add in multiple coefficients to balance the chemical equations. Now, this particular topic is found to be very difficult for even senior VCE students as well. But by going through these examples, I'm hoping that this will help you guys a lot and make your experience in VCE a lot more easier. So we're going to look at the first example of here of where we need to add in multiple coefficients. So again, set up my table and list down all the elements. We can see that there's 1 aluminium, there's 3 bromine, 2 potassiums, 1 sulfur, and 4 oxygens. There's there's 2 aluminiums on my right hand side. There is 1 bromine. There is 1 potassium. Now notice that you've got a polyatomic ion. So the number of sulfur atoms in the product is 3 multiplied by 1, which is equal to 3. And the number of oxygen atoms is obtained by going 3 multiplied by the number of oxygen. So therefore, this will be 12 in this case. Again, what you need to do is balance the chemical equation. So in this case, we can see that everything is not balanced at all. So let's firstly balance the number of aluminiums. So since in the left-hand side or in my reactant, there has less amount of aluminium, I'll have to add in a coefficient in front of this guy over here to balance aluminium. So I'll add a 2 here. By adding 2 over here, this will change the number of aluminiums as well as the number of bromine atoms in total. So now this is 2, so this is now balanced. But this affects the number of bromine atoms. So now you've got 2 multiplied by 3, so 6 bromine atoms in total in my reactants. So now what I need to do is balance the number of bromine atoms. So in this case, I'll have to add in more bromine atoms on my product. So I'll add a 6 in front over here. So by adding a 6 in front, this affects the number of potassium as well as bromine. So now you've got 6 bromine atoms, but you also have 6 potassium atoms in my products. I'll now have to balance the number of potassium atoms. So in doing so, I need to add a coefficient in front of K2SO4. So what I need to do is, therefore, since I'm trying to get it to 6, you'll agree with me that I need to add in 3 groups of this. And by having 3 groups, this will now balance the number of potassium. So now I have 6, but effectively this changes the number of sulfur atoms as well as oxygen atoms. So I've now got 3 times 1 sulfur atom, so that's 3, and 3 times 4 oxygen atoms, which is 12. Now, by adding a 3 coefficient, this kind of neatly balances the other atoms. So now this particular chemical equation is completely balanced. Now, this is pretty overwhelming, but this is how you would actually balance the chemical equations when you need to add in multiple coefficients. Now, again, when you're writing down the full chemical equation, this is how you should be representing it. Now, notice that I've got a blank over here. This blank indicates a 1, so we don't generally write a 1. So that's why I've left this part over here blank. So make sure you are doing this to answer the final question. What I'd like you to do now is I'd like you guys to actually practice by answering the following questions shown below. I actually don't have any solutions for these questions, and what I want you to do instead is once you've actually answered them, I want you to please send me your working out so I can show you the solutions, because I want to see physically whether you were able to get it correctly or not, or whether you've been copying my answers from previous videos. So please answer the questions. This will probably take you maybe 20 minutes or so to answer. And once you've completed, share answers with me through email, and then I will send you the solutions. We're now going to be moving on to the next topic. So in this slide over here, I've said sometimes we might encounter examples that are not usually shown or studied at the year 10 level, where we can't balance a chemical equation because you see an odd number. Now, what do I mean by this odd number? Let's look at an example shown on the next slide. So in this chemical equation over here, let's try to balance a chemical equation for this particular reaction. So as what you normally do, we set up the table and list down all the elements, count the number of reactants, and count the number of products. So if you do this, we can clearly see that the number of potassium and chlorine atoms are now balanced. We need to balance the number of oxygens. To balance the number of oxygens, notice that on the right-hand side of all my products, you've got less oxygens over here, so we need to add in a coefficient in front of oxygen gas to balance the number of oxygens. However, you should have the basic mathematical understanding and knowledge to say that if you add a number in front of O2, this won't give you a 3 at all, because any number multiplied by 2 will give you an even number. It won't give you an odd number like the number 3 at all. So how do we overcome this problem? Now, there's actually 2 ways to answer this question. There's the mathematical way, which is a lot more time efficient, and there's the visual method, which kind of makes sense, but it takes a lot longer to do if you were actually doing this in an actual exam. So I'll show you the mathematical way first, a more efficient method. Now, since I want to balance the number of oxygens in the products, what I do is I need to find out a decimal or fraction so that when it's multiplied by 2, this will therefore give me 3. So this is a bit of trial and error. So therefore, find a number or find a decimal that when multiplied, this gives you 3. So in this case, if you multiply this by 1.5, 1.5 multiplied by 2, this will give me 3. And by adding a 1.5 in front of the O2, this now balances the chemical equation. Now, you might agree with me that this is incorrect because we can't actually add in a fraction, because we know that a chemical equation must have whole numbers. So how do we actually avoid this problem over here? What we can do is, if we multiplied all the coefficients in the actual equation by 2, this will get rid of that decimal. So for instance, if I multiply this by 2, this by 2, this by 2, this will eliminate that. So in this case over here, because I've got a blank, that indicates 1. So 1 times 2 is equal to 2 in this case over here. 1 multiplied by 2 gives me 2, and 2 multiplied by 1.5 gives me 3. So now this is the complete and correct balanced chemical equation for this given reaction. And we can actually test this and prove this by counting the number of atoms shown below. So now everything's balanced, so therefore this indicates that this is correct. Now I'll show you the other method. The other method is less time, it's more time consuming, but it also makes sense though. So I'm going to show this visually. So what I'm going to do is show the diagrammatic version of each of these substances in my reactants as well as my products. So this is the chemical representation for my reactants, so for KClO3, and I'll do the same thing for my products in this case. The reason why it's leaning to the left is because, as you can see, there's more atoms on the left-hand side, which is why it kind of weighs it down. We want to try to balance the equation by having the same number of atoms. So we can see that in my reactions products, the number of potassium chlorine atoms are already balanced. It's just the number of oxygen atoms. So what I do is I need to add in more oxygen atoms by adding in an extra molecule of O2. I can't just add in one oxygen atom because oxygen doesn't exist by itself. It exists as a pair. So by adding in a pair of oxygen, this will now change the number of oxygen. I need to add more oxygens on the left hand side now to balance the number of oxygens. Because oxygen comes as a package in KCl3, I need to add in another molecule of KCl3. By adding in another molecule of KCl3, this effectively changes the number of potassium chlorine. So I need to add in potassium chlorine on my right hand side to balance this out. Now that my K and my Cl is now balanced, I need to balance the number of oxygens. So I've got 6 oxygens on my left hand side. I've got 4 on the right hand side. To balance the number of oxygens, I add in another molecule of oxygen, and in doing so, my chemical equation is now balanced. I've got equal number of atoms on the left as well as the right. So therefore, your final answer for this question, you would add a 2 in front of here because you've got 2 molecules of KCl3, you've got 2 molecules of KCl, and you've got 3 molecules of oxygen. As you can see, this is a lot more time consuming, but if this method works for you, then please use this method. There's multiple ways of arriving to the same answer, but obviously this takes a bit more time though. What I'd like you to do now is just to gain some more practice by answering the following questions as like the other questions. Please answer this in your exercise book, and once you finish answering the questions, please submit your answers to me so I can see whether you're on the right track or not. Don't get discouraged if your answers are incorrect. These are very complex examples and you are going to get more experience and practice at the VCA level, but obviously at the VCA things are learned at a higher pace, so you might not understand it completely then. So if you can understand it now, this will really prepare you for VCA chemistry. This is the end of today's video. Hopefully this video was very helpful for you guys. Hopefully you guys also enjoyed it. I'll see you guys again in the next video. Bye.